Hello and welcome to another DDMT tutorial video. Today we're going to be doing some dead reckoning, a old nautical process where we can begin to construct tracks once we know the animal's heading and speed. So first things first, with dead reckoning we usually have GPS locations to not only correct the track where needs be, but also ensure that the dead reckon process is accurate enough. When we're loading GPS data into DDMT, it needs to be in a very particular format. Let me just show you. So today we're going to be looking at goat data, and I've already formatted this data file to show you as an example. The data file has also been set to local time because the time needs to be the same as your daily diary data. Then some of the locations have been cleaned because when GPS is sometimes taken irregularly, you can get really inaccurate, unreliable locations. So I've opened up this CSV file in Excel. Your GPS needs to be in this specific format. The first column is date in this specific style where we have day, month, then year separated by a slash. Then we have time. Then we have latitude first, longitude second, and then you can have altitude. If you don't have any altitude data, put the column in, but then you can just list it all as 0. The naming of the columns need to be exactly that. The GPS locations need to be in decimal format, and if the GPS data won't load in, this is likely the issue. Just to remind you, it needs to be in a CSV format. So if I go to Save As, you have this common delimited .csv format that you need to save your data in. Let's bring in DDMT control panel here. So nothing's been loaded, just open DDMT up and we have this selection to preload GPS data file. This needs to be the first thing to do if you're using GPS data within DDMT. So I'm going to click the orange button and we can go ahead and find the data. Once that's loaded in, we can then load in our daily diary data. Ensure it's the correct ID or the correct corresponding data. Make sure you set your working directory because that's where any exports are going to go. I'm just going to leave that as the desktop and then load data. Let's bring in the drawing. So this device actually got switched on and left to run, so we just have a flat line at the beginning. But let's just check our GPS data is there. So we go to Show 3D, right click to bring up the 3D controls menu, and you can just click GPS, and as long as it gives you all your GPS points, which I do there, then your GPS is successfully loaded in. I'm just going to add a line function to ensure everything's there to make it a bit more clear. So we go right click on the first button, down to data, pixel / line select. I'm just going to roll with my mouse wheel. Perfect. So they're all interpolated there. Delete that. Next, I'm going to load in my TDO because I need the local time to come in to then sync up my GPS points. Once the TDO is loaded in, we're going to go and check the heading is working on our calibration. So I'm going to go find the split where the calibration began. Now, as a part of this calibration, we stimulated the 3 acceleration, did a quick sort of tumble to fill our M spheres, and then we spun on the spot. And the reason we spun on the spot, holding the device at each point of a compass, was to see if our heading's working correctly. First thing, I'm just going to check that my TDO file has loaded in correctly. Yep, my mag data looks good. Next thing, I'm going to bring up a heading wheel, as this is going to show hopefully the 8 points of a compass during that last phase of the calibration. So we're going to go 2D sliders and then we're going to select pitch roll / heading, and here we tick the display simple 2D compass on graphing window, and there we have our compass. We can move this by holding shift and dragging, and if we go over, we should have those 8 points. So north, but it's a bit off, northeast, east, and so on and so forth. Perfect. So it looks like our compass is working. Next thing, let's go find some goat data. So here we have some goat movement. I'm just going to move along half a split. So the whole split contains goat movement. Now we know the heading's working. We've accessed a split where it's all animal data. We want to check that our GPS points are there, and we can do this by using the drop down menu on 2D sliders. Go to GPS, and then you can tick this to show GPS fixes by time, and they'll pop up as blue lines with red dots. Now, if your GPS isn't popping up, there's a quick fix you can try. Go to the GPS tab and then click the sync GPS file to DD, because sometimes it doesn't always automatically sync. Once that's complete, you should have these markers every time you have a GPS point. To dead reckon, we're going to roughly make sure we start at a place where a GPS point begins and end at where a GPS point finishes. To produce an initial dead reckon plot, we can click Show 3D, then use the right click to display the 3D options, and all we need to do is click Dead Reckoning. And that's the unpolished dead reckon track. I'm just going to use the Shift and clicker to move this menu. Here are some worthy controls to note down. So we can not only move our 3D track round, and it uses 3 dimensions by using the pressure as a proxy for altitude. But if we right click the first button and right click the next button along, it displays even more buttons, all labeled clearly on what they do. Let's just go over a couple. So first things first, within Dead Reckoning, VEDBA is being used as a proxy for true speed, but the data to be plotted needs to be defined by defining movement. One way in doing this is the VEDBA threshold. So if we select Set Movement Threshold and Coefficient with the left click, this shows that any VEDBA value above 0.1 will be regarded as moving and be used within the dead reckoning process. But this can be altered, so we can halve it, which will make the track bigger. Or we can make the value larger, which will make the track smaller because less of the data will be used. But I'm just going to put it back to the default. To explain the coefficient value, this is how much VEDBA is multiplied by to give an accurate reading of speed. To understand this better, let's overlay the GPS. To bring in the GPS data, we use this third column. For this, we're going to use the purple button selected. Now, if we go over to the second purple button down, it says Inherit Starting GPS Coords. If we enable that, we are then able to overlay our GPS. So if we select that, we get our GPS points come in. Now, I'm just going to quickly change these pixels to lines to make it a bit more clear as what's happening. Now you can see that a similar shaped path is being produced, but it's much larger, which means this coefficient value needs to change if we're just dead reckoning alone. So let's make this larger Oh, it's a bit too big. Okay, that's about right. Seems like it could be rotated a few degrees to actually match up. That's to be expected. This data isn't very high quality as the data is collared data, so there's a lot of noise, swinging and different motions going on. But it gives you a good idea of how dead reckoning alone can give you a good estimate of location. Now, if we scroll through the data, you'll see as the GPS extends, so does the dead reckoning. And when the GPS holds position, so does the dead reckoning, really displaying the strengths of this analysis. So we can also use marked events to define movement. We don't have to use Vedba threshold. In this example, I'm going to load in some defined steps. Going to select the steps behavior. My steps take about a second each time to undertake, but my definition only picks out the peak, so I'm going to extend half a second either side of the peak. And mark my events. Okay, you see in red every time the animal steps. Now we can actually only dead reckon these marked events. So in the second column along, if we select dead reckon by marked events only, enable, it brings up coefficients, but for every marked event. Now my path is a lot smaller as there's so much less data to dead reckon. So let's try and extend this a bit larger maybe. So I took down my Vedba threshold to 0, as if you have the Vedba threshold implemented, it's going to do a double filter. It's not only going to take your marked events, but it will only plot marked events that surpass that Vedba threshold. So I've left mine as 0 because I'm confident that my step selection or my step definition is sufficient. You can also change these values based on a behavior, for example, grazing. So grazing is actually going to be a inefficient behavior with regards to moving relatively compared to actually walking in a straight line. So in other words, you can have lots of high activity and random peaks while the animal grazes, but realistically the animal isn't going to move very far because some of that activity is the neck swaying as it's selecting what grass or patches of vegetation. I'm just going to go back to the Vedba threshold for the example. And the next thing I'm going to show you is how to GPS correct. This is where for every GPS point, the dead reckon path will be corrected in heading, so rotated, and also the path will be extended or limited based on a secondary coefficient value to fit between the two GPS points. We're going to check that the GPS point has been inherited. It's overlaid as shown here, and all we do is click GPS correction. And there we go. From there, we have GPS corrected dead reckoning. Now you want to export this path, so there's two ways of doing this. One method is to push the path onto the array, in other words, push the locations onto the data. You do this by using the second button down on the last column here, clear the DR main array, and then you can auto push the DR data to the main array. So right now, each data point within DDMT has a dead reckon location. You can then export this by selecting in the input output what to save, additional metrics, and ensure that dead reckon long latent alt is ticked. If you make any changes or amendments to your path, you need to make sure you clear the main array once those changes have been made, and then auto push the dead reckon data onto the main array. A quick method of just directly exporting the path is you can select on the fourth button down on the last column, continuous calculation of dead reckon from this point, and export. So what you do is when you're highlighted this button, you can use the mouse wheel. You see it going up. You can go to any split within your data. So for this example, I'm going to go just to split 9. And if you left click, it will continually export your path with any channels or variables that you selected within your what to say function. That was a brief tutorial on how to dead reckon in quite a basic manner. There's different ways you can perfect the method by ensuring your data's good quality and raising the quality of your data, by smoothing out the VEDBA so it represents the true speed of the animal better during transition, smoothing out your mag data so your heading is smoother and represents the changing heading of your animal. Those things can be played around with, and a lot of time can be poured into really polishing up your paths. But for now, that gives you a crude idea and is a great way to estimate your location between low resolution GPS points.